Welcome back, everyone. We are honored to have Professor Henry Wong, our Regional Director, with us today. May we first invite Professor Wong to say a few words to our teams? Professor Wong, please.
Hey, dear students, good afternoon. My name is Henry Wong, and I'm in charge of the Yale High School Science Award Asia. On behalf of the governing bodies of this award and also the Hong Kong Academy of Sciences, I wish to thank you for taking part in this Zoom competition. Today, we have 5 teams from India, Singapore, and Hong Kong. The format of this competition, unfortunately, has to be conducted online due to the COVID-19 pandemic. But this doesn't seem to have a detrimental effect on your outstanding research and your presentation. Now, at the end, you are all winners. Okay, now I won't go to give a very long speech, so it's now the most exciting time. I would like to invite Professor Wang Yao, the panel chair, and the other panel members to make comments on your work. Then Professor Yao will announce the winners. Professor Yao, please.
Thank you, Professor Wang. First, I would like to thank all the teams for participating in this year's competition, including those teams who are not here today for the oral defense. As a physicist, we are really glad to see so many high school students have passion in physics research. Compared to other branches of science, physics is a well-developed discipline, and it is really difficult to find projects that are suitable for high school students that have not been done in the literature, while meeting the criteria of originality, creativity, and having impact. But I'm glad to see that you have identified interesting projects to work on. Today's projects may be put into 2 categories by my observation. The first is physics in daily life, mostly curiosity-driven. So we have projects studying flying motion of badminton and cars. We all have experience with this phenomena, but physicists could be too busy to do comprehensive studies on these phenomena. So these are places where you can identify things to work on to examine the non-trivial manifestation of known physics principles. And you may need to think a bit more about that's the impact. What is the impact of such research? And the second category is to address the grand challenge of the human society. And we have seen projects mainly on the energy generation and the consumption issues today, which are more engineering oriented. So these projects certainly have impact, but I want to emphasize that this is a competition for science award. So we do look for innovation and originality in scientific content. So in solving the engineering problems, put something to work or show some functioning is not enough. And we hope you can go deeper into the physics. And next, I would like to invite my colleagues on the panel to comment on the individual project in the order that they are presented this morning. So Professor Key, would you like to start with?
Yes, okay, thank you, Professor Yao. So yeah, I will start with a comment on Team Physics 0152 who studied the physics of badminton motion and its fun. So actually, as Professor Yao already mentioned, you chose a topic very well because badminton is probably one of the most popular sports that everyone should have played at least once in their life. And it involves quite complex motion of the shuttlecock, which is indeed an interesting physical problem. But however, we found several important components that are missing in your work. I will just summarize it into 2. So first one is the problem was oversimplified. So there are many key features that are missing, such as flipping of shuttlecock and how the how the shuttlecock flips in a way that you can actually kick the head of the shuttlecock individually in the opponent. And also, secondly, it seems that there is no experimental verification of the model that you use in the study is given. So yes, so then, so of course, the shuttlecock motion is quite complicated, but it could be very difficult to solve it mathematically in high school level. But still, you could have designed and carried out some simple experiments to verify your model and needs in your level. Yeah, so that's the kind of two major comments that I have. And then, but thank you for your work. Actually, the topic was quite interesting indeed.
Thank you. And Professor Zheng, would you like to comment on the next?
Sure. Thank you, Professor Yao Wang. And then what I try to comment is on the physics 0 to 42 reaction on motion of the flying playing card. So first of all, I would like to congratulate the team on working on a daily life topic, but then done it in a very deep way. So you have done good analysis theoretically to understand the situation using numerical model and using a computational simulations, as well as experimental setup to evaluate and examine your theories. So the panel feel that you have done some thorough study on this. We also have a few comments that help you to improve your project in the future if you continue to do so. From some minor point of view, we believe that you can add a little bit more about experimental errors to your experimental results that give you more convincing data. The second one is that we may suggest that you'll be able to measure the angular velocity in your work, which is one of the most important parameters. And that can be simply done by putting down some fluorescent light emitting materials on the car and tracing this light emitting tracks in a dark room so that you can actually know that the rotation speed. The third one is that I think Professor Yao Wang also mentioned that how would you be able to express the impact of your fundamental research in a wider context to see in this kind of a low velocity motion, how can it be used, for example, in some kind of a shooting or in some kind of a motion targeting, for example. And that's something that you guys may go back and think about more in the near future. Thank you.
Thank you. And Professor Song, please.
So yeah, I'll be commenting on project PHY034 and the multi-weather power system from Bangalore. And you know, the committee thought that there was this interesting project. It's kind of a daily life kind of thing whereby, you know, we always see rain coming down, and one might wonder, in addition to using solar panels, you know, might one be able to also harvest some kind of energy from these weather patterns. And so this was an interesting idea, and the team made some effort into trying to address this. They tried to measure, you know, the effect of raindrops on resistivity in a kind of a simple system, and they tried to build a system. But with the panel felt that, you know, there distinctly some things that were lacking in this project. In particular, what we found was that there was a lack of a demonstration of any kind of energy harvesting. So we weren't able to see any kind of real power generation in this system, and actually having some kind of power generation would have been helpful to kind of evaluate the usefulness of such a strategy. And in the absence of such a demonstration, I think it would have been also helpful to even just estimate how much power one could theoretically kind of extract out from just raindrops kind of falling down these things would have helped to improve the project, and actually would actually help us to understand better how such kind of piezoelectric type strategies might help in energy harvesting. So we still thank the team for good effort.
Thank you. And Professor Yang?
Thank you, Professor Yao. So the project I'm going to commenting is a project PHY050. So the project to harvest energy from human motion. So this is a wheel select topic. So the topic is try to collect some energy from the motion of human body. So it's an interesting idea. And he single-handed did everything, including the design of the device, putting up the device, and test the device. So just single-handed did this project is quite a work. It's a very good project. But we have two comments. The first thing is this kind of electromagnetic induced energy harvesting way have been done for more than 100 years, right? So people long time use these hand crank energy generators with the exact same principle. So from this point of view, the novelty is still a little bit lacking, because also another thing is the student should not only just say, I demonstrate idea, but also this is a physical world. So in this case, you have to do a systematic study, starting from present the idea, theoretically analyze the idea, maybe do some simulation or do some calculation, and then demonstrate this thing, but also with systematic analysis. So for example, compare with other traditional way of generating energy by motions, and what is energy efficiency. So all kind of this stuff will actually more put this work towards a physical research than just a small invention. So also, I think from the idea point of view, right, this idea is kind of motion generates energy by electromagnetic induced. This idea have been for many years. So in some senses, a student may also try to look into something not that textbook idea, right? So because this kind of experiment people already did in your high school experiment most likely, but try to think about some idea really from your common life, and there are tons of things actually around it. Just stick to this physical experiment, right? There are physics are so broad with so many different disciplines. There are so many things around you that you can find a good topic on it. So that's my comment. But overall, this is a good work done by a single person. Thank you.
Thank you. And Professor Han, please.
Okay, I will comment about the team physics 41. They use machine learning algorithms to improve the temperature feedback of a heater. And nowadays, it looks like a fashion to apply various machine learning algorithms to solve all kinds of problems. And I think they choose a good topic. It's relatively simple and quite meaningful, useful for real applications to improve the performance of a heater. They did some simple experiment and wrote computer code for several algorithms of deep learning algorithms, and the results are good. The performance is dramatically improved comparing with the conventional method. Their best algorithm can eliminate the overshooting problem and reduce the equilibration time. So basically, it's a successful project. On the other hand, our panel member think that some parameters in your conventional algorithm can be improved. Also, it's an engineering problem, project. It's not 100% fit our the scope of this award. As the chairman of the panel, Professor Yao said, it's better to have deeper analysis on physics. Okay, that's my comment. anything you want to add?
Thank you. And Professor Feng Wang, do you have anything to add? You are muted, so please unmute.
So I have, can you hear me now?
Yeah.
Okay, so I have some additional comments also for the project 041. So this actually is a very important topic that you want to save energy. So the problem is there already exists very important, very widely accepted PID system. So here you propose a new system. You claim it's have a better performance than the existing one. So in such case, you need to provide a very convincing evidence to convince people your new system is really better than the existing one. But according to your presentation this morning, as the data you shown is not sufficient for us to believe that this is really the case. That in the future, if you want to convincing people your new Q-learning based controller is really better than the PID system, you need to add more experiments at different use different parameters at different temperatures, for example. So another thing I want to add is that so if you want to convincing people your system is really good, also you need to consider the cost. If there is a significant increase in the cost of the system, then people may not like your system either. So that's two things I want to add.
Okay, thank you. And thank you all for the comments. And I hope a student can find these comments useful to improve your project. And more importantly, to have a better idea of what physicists are looking for in scientific research.
Thank you, all panel members. Now comes the exciting part. So we now invite Professor Wang Yao, our assessment panel chair, to announce today's competition results. First, certificate of participation. Professor Yao, please.
Okay, thank you. So first, I would like to issue the certificates of participation to team 052 from GT College, Hong Kong, and to team 034 from International School of Bangalore, India. Congratulations on completing the interesting projects.
Then honorable mention. Professor Yao, please.
Okay, so the honorable mention goes to team 050 from International School of Bangalore, and the team 041 also from International School of Bangalore, India. Congratulations.
As we do not have any silver prize winner this year, we'll go ahead to announce the gold prize winner. So the gold prize will receive a cash prize of $1,000 and be recommended to compete in the finale in Beijing. And this year's gold prize goes to Professor Yao, please.
The gold prize goes to team 042 from Hua Chung Institution of Singapore. Congratulations.
Thank you, Professor Yao.
Congratulations to all teams. We will courier the trophies and certificates to all winners. So this concludes our program today. We hope you enjoyed the competition. Stay safe and goodbye.
Goodbye.